I believe it was in our last video when we were looking at frequency distributions. So we're in chapter 2, organizing data. We're continuing. So we looked at qualitative frequency distributions. That's where the data did not have numerical value to it. So we talked about like male versus female, religious affiliation, blood type, those kind of things. Would not have a numerical quantity to it. So we're going to talk about a quantitative frequency distribution, a quantitative frequency distribution involves, what's up with this mouse thing? I don't like it. Involves quantitative data. I'm using a ViewSonic right now, and it's strange. Okay, it has a little mouse touchy thing. So this time the data is going to be numerical, and classes for quantitative frequency distributions, quantitative frequency distributions, consist of groups of numbers. So numbers grouped together consist of groups of numbers. So let me come up with an example here. Dude, you're supposed to scroll. You're not supposed to write. What's up, man? Okay, here we go. Let's do an example. Come on, man, you're supposed to write. Example. So we got a situation. Consider the frequency distribution for employees of a company. All right, so here's the frequency distribution. So here we're going to have a number of children on this side. And on the other side, we're going to have our frequency. Let me scroll up. So here we got from 0 to 2 children. Here we got 3 to 5 kids. In our last class, 6 to 8 kids. Now, these are actually going to be our classes. So we said when we're dealing with quantitative frequency distribution, the classes are going to have groups of numbers. So from 0 to 2 kids is a group of number. From 3 to 5 kids is a group of numbers. And from 6 to 8 kids, it's a group of numbers. Then we got some frequencies. We got 10, 4, 1. All right, so part A, question. We're going to try to interpret this. What are the classes here? So remember, the classes are always on the left, the frequencies are on the right. So classes here represent number of children that an employee would have. Number of children an employee has. Number of children employees have. Number of children employees have. Okay. Next question. Let's scroll. Scroll, scroll, scroll. Pretty cool, huh? B. Second question, B. What does the frequency column tell us? Doesn't write too well. Tell us. Let me try to erase that. So anytime you write on cursive on this thing, this ViewSonic, it goes hayward. What does the frequency column tell us? So let's go up. Let's look at the frequency column. I don't want to do that. I'll erase everything. So the left-hand side tells you the number of children that the employees have. So the right-hand side, frequencies, this would be the number of employees right here. So you've got 10 employees that have between 0 and 2 kids, 4 employees that have from 3 to 5 kids, and 1 employee that has 6 to 8 kids. Your answer is the frequency column tells us how many employees. How many employees have a certain number of children? A certain number of children. So let's do part C. C. Construct a relative frequency column. Misspelled column, let me put an N there on the end. So remember what relative frequency is the proportion or the percentage of the time that something occurs at a particular frequency, or that a class occurs, rather, a class occurs. So what we do, we're going to make an extra column here and call it relative frequency. I'll do it in red here. I'm going to abbreviate it. I'm running out of space. I'm going to make a little extra thing here to do my computation. So my computation, my scratch work's going to be in green, I guess. So first of all, what you're going to do, you're going to tally up the total of all your frequencies. 10 plus 4 plus 1, that's 15, right? And then you're going to take the frequency here divided by 15. What's 10 divided by 15 is the question. Well, 10 divided by 15, if I do that, is going to be 0.6 repeating, right? All right, then let's do 4 and divide that by 15. 4 divided by 15, that's 0.2, and a bunch of 6s repeating. Keeps repeating. Then we do 1 divided by 15, right? 1 divided by 15 is 0.06 repeating. That was a 2 over there. All right, so when you're doing relative frequency, you want actually percentages. So to make a percentage, you're going to move your decimals 2 to the right and put a percentage sign. So the first one, we move the decimal to the right, we're going to get 66.6 repeating. To get 6 repeating, I put a bar over the 6, and then I put a percent sign. So 66.6 repeating percent. The next one, 0.2 with a bunch of 6s. That's going to be move the decimal to the right. You're going to have 26, and then the 6 is going to be repeating. So we put a bar and then a percent sign. And then finally, the last one, 0.0666 forever. You're going to move the decimal to the right. You're going to have 6.6 repeating forever percent. Now, if you're to add these up, you should get 100. 66.6666 plus 26.666 plus 6.666 forever. You get about 99.999, bunch of 9s, right? The only reason you don't get 100% exactly is because you couldn't write out all the 6s. So it does add up to 100% if you're able to write out all the 6s. Oh, that's scratch work, so I'll do it in green, right? Let's do it in green. I'm doing scratch work. Scratch work goes in green. You don't have to write the scratch work, but the important part is the red stuff there, that relative frequency. Okay, so that means roughly 66.6 people have between 0 and 2 kids. 26.6% of employees have 3 to 5 kids, and it's only 6.6, about roughly 7%, right, of employees here have from 6 to 8 kids. Not many people have that many kids. All right, I think we're probably going to stop there and pick up in another video.